Oh. Did we forget the recorder from the get-go? Is that what that is? 10,356. And then 10,356 here times 0.03. Do you see why we couldn't add 276 each time? I mean, if you look here, this is 26 people more than them. So we would be losing out on a bunch of people. This equals 310.68 plus which comes out to 10,667. So there are our 5 answers for that. I know it's a lot of work, but it's 3% each year. The population has changed at the beginning of each year. So why would we not account for that, right? Well, we're going to. Okay. A community pays salaries and wages of $175,000 annually to its utility employees. If 19,000 of this amount was spent on overtime, what percentage of the total does overtime cost represent? So what's the whole thing? Part of is 19,000. So 19,000 divided by 175,000, which is part of the whole, and get 0.11, 2 decimal places. So I go 1, 2, and you get 11%. Okay. So that is fractions and decimals and percents. You're going to see the ones that say problems like this at the top. These are, you guessed it, homework. But before we get too far along, or before we take our break, I want to go over page 12 real quick with you. Okay. I want to go over page 12. So if everyone could turn to page 12 real quick. Just so you know, there is answer keys in the back of this for all of these homework or extra problem sets for you to do on your own. There is an answer key for them. Okay. So I want everyone to do question number 3 real quick. Okay. So go ahead and do question number 3 here. 810 divided by 8 times by 6. Okay. And so I'm gonna give everyone a couple minutes while I do number 3 here, and then it'll be talking about some stuff. All right. It's been like a minute. Okay. So my guess is you guys are going to get one of these 2 answers, right? So those of you who are watching with other people, you know, if someone, you know, it would be curious how many got this. And if you got that number, I'm going to tell you you are wrong. And you're going, what? I'm wrong. What do you mean? Well, my teacher taught me. They taught me, please excuse my dear Aunt Sally, right? It's a phonogram, meaning how it's called for the order of operations, some of you may recall, or PEMDAS, right? Well, you multiply before you divide. So I multiplied here, I got 48, and then 810 divided by 48. Bam, I got 16.875. And if you got that, this is wrong. So order of operations to you, and any of you who did this, were taught wrong. And I know that's a good thing about this being online. We can't see who did it wrong, right? Can't be like, raise your hand. So, so don't be embarrassed. It's because order of operations was not taught correctly to you, okay? So I teach order of operations in order of degree, okay? There's first, there is second, and then there is third degree, or what you do first, second, third. Okay, so there's parentheses, there's exponents, which is, like squared, and then there is square root. Then there's, on the second level here, you have multiply and divide, and third you have add and subtract. Okay, well, so this is what you do first, second, and third. Well, and you're looking at this going, well, that isn't any different. But there is a difference. When on the same level, it is left to right. So you read a book left to right, correctly? Like, I am going to the office. That's a sentence, and that's how you read it. I'm going to the office. So look at question number 3 here. Are you on the same level with the divide and the multiply? They are both level 2, meaning you would go left to right this way. So you're going to go 810 divided by 8, which is going to give you 101.25. Then you're going to multiply that by 6, which is going to give you the 607.5. Okay. So see the calculator here? Can we all agree that the guy who made this calculator or designed this thing is probably smarter than every one of us on this call? I mean, maybe not. Maybe someone out there is the guy who designed it that's on the call. But chances are probably not. So we'd all agree that the guy who designed this thing is smarter than most of us, right? Well, okay, so 810 divided by 8 times by 6. You can see this is what that question is. I typed it in, right? 607.5. This is part of the reason why this is a scientific calculator. The order of operations is built into this thing. I told you how it's supposed to work, and I think I proved my point, correct? All right. So with that note, let's go ahead and do our 10-minute break, and then we'll come back at like 9:40 for a poll question and unit conversions. All right, everyone, we should be getting back from break. It was technically like 9:41-ish or 9:31 when we went to break, but everyone should be getting back now. You do have to respond to the poll question here. Matt will take over on that regard.
Okay, we got the second poll question here. And I'll go with this one. Just to kind of get an idea, is this your first time taking a math course since high school or college? So if you want to take a moment to answer that, and again, you have a little camera looking character that's on your toolbar. If you click on that, that'll make GoToWebinar your primary window. Strongly recommend that if you are taking these classes, you are doing so on a computer so that you can actually see the screens, participate in the polls, and really get the most out of this course. So we're up to about 85%. Again, if you're having issues with the poll question, please let me know by using the Q&A questions function. And if you did not notice or you arrived late, I've been dropping copies of today's handouts in the chat. Just got a question on one of those if that is available. So I will re-drop it again. So if you did join late, you'll at least be able to click on that handout and download those for your use. So stalled out here kind of at about 87%, a little bit less of you have taken the poll, the second poll than you did the first poll. So I'm just going to let it run because we are just coming back from break. Hopefully people are aware that there is a poll going on right now. Again, click on the little camera in your toolbar, Windows toolbar, that'll bring Zoom as your primary window on your screen. And then you should be able to select poll answer and hit submit. And Scott, while this is running, just to kind of give you an idea, 44% of the respondents are indicating that, yes, this is their first math class since high school or college. So pretty significant.
I will say that's not uncommon or unheard of. So Matt, you guys are still doing follow-up like opinion forms on these classes, correct?
Yes, we are. We're not doing them after every session. We'll do them at the conclusion
end of the
class, course. Yeah.
Okay. Yeah. And when you guys get that, basically what it'll be is it'll be an email opinion form of how you felt about the class with I think some written sections in there. And we really do care, especially, I've been doing this for 10 years. Yeah. But it doesn't mean that I'm perfect at my job. All right. If there's anything that you feel we can do better or change or so on and so forth, please do let us know. I will say I have been eagerly working on a couple like more advanced standalone math sessions that are kind of like compacted together. One of them being fluoridation. We haven't offered that online yet, but we will be offering that one in person in Mount Pleasant on October 11th. It's a 4.5-hour math class worth 0.4 cc's, but it's specifically to fluoride. It's not to anything else. And I just put together a chlorine session in the same fashion, where it's a 4.5-hour chlorination standalone session that we'll be teaching. We're pilot testing it in October, so it's not a done deal yet, but it's a pilot test. The fluoridation has been piloted, so we are like for sure and set on that that's good to go. But the chlorine will be new. But I'm working towards that. I'm working on writing another chemistry session at the moment. I'm working on trying to develop more trainings for like filtration and ion exchange softening calculations and that kind of stuff, like standalone sessions that these things are for more advanced users. It's good to hear that, 44% of you, this is your first math class. So I really want to know from you 44% or even more, what you think, as in, is this helpful? Did I break it down nuts and bolts approach like I always do enough that you can understand it? Because that's my goal, is to make sure that everyone has a fair chance at understanding the material, because I try to take a nuts and bolts approach to every class and everything I teach so that everyone can understand it. I come from a poor farm family up north where, I was taught lots of things hands-on, baling hay and how to drive tractors and the whole 9 yards. And I very much agree that if you're going to learn something, it's easiest to learn from not preaching down to you or acting like I know more than you or anything like that. So that's the approach that I've always took, and I hope that that comes through with the stuff.
All right, Scott, so I closed the poll. It ran for over 5 minutes. So if you want to reshare your screen again, you can pick up where you left off.
All right. Okay. So we
right.
left off with talking about order of operations. And I showed you how the order of operations works, okay? So, and right after that on page 13 is units and conversions, okay? So units and conversions are the quote unquote absolute must that people must understand in order to get, all right? And what I mean by that is unit and conversions, or unit conversions, are the quintessential part of all the math you're going to do beyond this, okay? And the reason for that is we are given, or you will be given, different types of units in the questions, and you typically have to solve for them and figure out where you're starting and where you're going, kind of thing, all right? So with that being said, let's dive right into it and how we do them and get some practice with doing some, all right? Because there is a couple of different methodologies out there that exist, but the methodology for unit conversions I'm going to teach you today is the one that is universally accepted by everyone. It doesn't matter if you're doing a physics class in college or your kid is doing physical science in high school or even chemistry. The unit conversions I'm going to teach you are the unit conversions universally accepted in all sciences and all maths across every academics. And then I already hear it. Well, does that mean it's going to be hard? No, if it's explained to you the right way, doesn't mean it's going to be hard. Okay. So, hold on, let me pull this up, because this is something that's available to you in your. So there's going to be a math conversion sheet, all right? Formula sheet that was in the handouts. Just so you know, any of you taking the test, this thing is on the test. You can see there's some conversion factors here, okay? So I will try to go back and forth between this so you can see, so that you can kind of get a feel of things. But let's start with first talking about what we're going to be dealing with. Okay, the very first thing we're going to be dealing with is we're going to be dealing with conversion factors. And what a conversion factor is it's two different things that equal each other, okay? Like 1 foot equals 12 inches. 1 foot and 12 inches do equal each other. Would we agree with that? Well, that's written there. Let's think of one that I know, that we all know, that equal each other. So how about 1 hour equals 60 minutes? Would you agree that that is a true statement? My guess is all of you are going to say, yeah, of course, 1 hour equals 60 minutes. About 24 hours equals what? 1 day, right? We can agree that these are conversion factors. Something equals something else, okay? Well, there's something unique about conversion factors, okay? For the fact that these are conversion factors, they're also known as ratios. Well, ratios, according to the law of proportions, can be written as fractions, okay? Which means 1 hour over 60 minutes, or 60 minutes over 1 hour, okay? So the conversion factor can be written as a fraction, okay? And sometimes I get often, well, how can you do that? Well, if I were to multiply these together, let's just ignore this for now. If I were to multiply these together, 1 hour is on top here, 1 hour is on the bottom there, what happens to it? It cancels out. Here we have 60 minutes on the bottom and 60 minutes on top. What happens? It all cancels out and equals 1. So do you see that a conversion factor is one thing equals another and that it can be written as fractions, okay? Does that make sense so far? I hope it does, all right? So how do we use a conversion factor? How do we use it? What do we use it for? And why do we use it, right? Those are often the questions I get asked. So the thing about it is, we do it like this. So let's go here to the very first example where I have 8 miles plus 4 feet plus 50 yards. Okay, so I'm going to cross this off. That's okay. If you want to leave it, go ahead. I don't care, but I'm going to cross it off. Okay, so the reason I'm crossing it off is I need to get 8 miles plus 4 feet plus 50 yards in feet. All right. And I'm going to take what I start with, which is 8 miles, and I'm going to write it here. Okay, so is 8 miles a fraction? Do you remember what we learned with the laws of fractions? Well, yeah, of course, 8 miles is over 1. Okay, well, would you agree that 1 mile equals 5,280 feet? Maybe some of you know this, maybe some of you don't. I do believe it's on the conversion. Right here, 1 mile equals 5,280 feet, okay? As you can see. And we know that 1 mile can be over 5,280 feet, or 5,280 feet can be over 1 mile. Would you agree with that? We learned that a conversion factor can be written as fractions. There's 2 different fractions it can be written as. So what we're going to do is we're going to look at our 8 miles now. Our 8 miles is where? Is it at the top or the bottom of a fraction? Well, if it was on bottom, it'd be down here, so it's on the top. So the fact it's on the top, remember the second rule of fractions says if it's on the top, it must be on the bottom to cancel, right? Well, okay. So in this box or circle, we'll do circle. In this circle, the only thing you can write there is a conversion factor, okay? You only write 8 miles once, and that's when you start with it. So after that, you can choose to ignore it, kind of like this. So now the only thing I'm going to write here is going to be a conversion factor. Well, the conversion factor you're going to choose is going to be what you're starting with and where you want to go. So we have 1 mile equals feet, and I want feet. So 1 mile goes here. The only thing that can go above that is what's attached to it. You see how these two are attached by equal sign here? So if this is attached to it, that's what goes above it. Okay. And the same would be true if it was flipped. If 5280 was here, 1 mile goes up here because that's what's attached to it. But we decide what's going to go where by what we need to cancel. Miles are on top, miles are on the bottom. They cancel like that. Now I get, well, how do I do the math? Well, you go across the top this way and across the bottom this way. Well, 1 times 1 is what? 1. That ain't going to change anything. But this 8 times 5,280 gives me 42,240 feet. All right. Now I'm going to go down here to the 50 yards. I'm going to start with that 50 yards. Well, I know that 1 yard equals 3 feet. My 50 is over 1. So if my 50 yards is on top here, my yards is on top, where's it got to be canceled? Well, down here. Well, that would be 1 yard, and then the thing attached to 1 yard goes above it, 3 feet, which is 150 feet. So we add all those together, and we get 42,394 feet. All right, that's how unit conversions works. You write down what you start with, you pick a conversion factor that relates to 2, and then you go from there. Just go away there. That goes away. All right. Yards, I forgot to cancel. They cancel like that. Okay. So down here, I already converted yards. So I'm going to do inches. I'm going to start with 10 inches. It's over 1. Well, I know that 1 foot equals 12 inches. Okay. So I need to get inches to feet. If my inches are on top, where do they need to be to cancel? Down below. 12, and I need to get 1 foot is attached to the 12 inches, so it goes up top like this. And then you see we get 10 times 1 is 10. 1 times 12 is 12. So you get 10 over 12, which equals 0.83 feet, because that's the unit that's left, because inches cancel out. So they won't always just be multiply. They can sometimes be divide, as you can see with inches here. All right. So here, this is just some conversion factors that we're going to be using over the next few days. The big ones are 1 cubic foot of water equals 7.48 gallons. 1 gallon of water equals 8.34 pounds. That one I don't care about. This is 1 foot of water equals 0.433 psi. 1 psi equals 2.31 feet. These two, we're going to use a ton. This one, you get to pick one, which one you want to use, okay? Do you have to memorize them? No. Will you by default because you do so much math? Probably, if that makes more sense, right? This of the two here, this is an indication of static pressure hydraulics. This one is, okay? So we will get there on Thursday when we talk about that, is where you'll see that one come into play. But these two here, that 1 cubic foot is 7.48 gallons. So what that is saying is that if you have, it's a bad cube, sorry. If it's 1 foot by 1 foot by 1 foot like this. So imagine a 1 foot box in front of you. We filled it full of water. It's going to hold 7.48 gallons, okay? And I just want to indicate to you that that is not an exclusive thing to water. Will we use it mostly with water? Yes, that's true. But anything that's in liquid form, if we put it in a cubic foot, it will be 7.48 gallons. Does that make sense? Whether it be vegetable oil or alcohol or cooking oil or mercury for that matter, it will all be in there as 7.48 gallons. It's not exclusive to water. As you see, does it say of water? No. Just as saying, if you have a 1 cubic foot cube that you can fill full of stuff, whatever it is, as long as it's liquid form, 7.48 gallons will fit in it, okay? Now this part, 1 gallon of water equals 8.34 pounds. That is exclusive to water. Every liquid has a different weight to it per gallon, okay? All right. A storage tank holds 2,000 cubic feet of water. So I'm starting with 2,000 cubic feet. How many gallons will it hold? Well, I know that I just learned it that 1 cubic foot equals 7.48 gallons, right? So if 2,000 cubic feet of water are up top, where do they need to be to cancel? Well, cubic feet is on top here. It's got to be on the bottom to cancel. So put 1 cubic foot, and then it's 7.48 gallons here. Cubic feet cancel. 2,000 times 7.48, and we only have ones on the bottom here, so that does not matter. This is going to give you 14,960 gallons of water. 14,960 gallons of water. Well, at the same turn, now it says, how much does this amount of water weigh? Well, just learn that 1 gallon weighed 8.34 pounds. Now that's exclusive to water. So gallons is up top because it's over 1. Where would it have to be to cancel? 14,960 gallons is on the top. That means that gallons has to be here to cancel. How many gallons would it be? 1 gallon. And remember, whatever's attached to it is what goes on top of it. 1 gallon equals 8.34 pounds. So that's what goes there with it. Okay. And when I do this, I get 124,766.4 pounds. Here, these are rounded amounts. There's rounded amounts there. 14,960 is not rounded. It doesn't need to be rounded. It's a whole number. And this doesn't need to be rounded either, right? The reason that this doesn't need to be rounded is for the fact that it is not the 2 decimal places. Okay? So the next page is the same stuff I've already told you. Page 16 says memorize these. You don't need to memorize them. They will become ingrained in your head just because you use them so much, but you do not need to memorize them, okay? So I'm on page 17 at the top here. And another reason you don't need to memorize them. Hey, look right here, right? The math formula sheet. All right. Sorry, I'm trying to do something here, guys. So that's where our stuff comes from. Okay. So now I stopped here and it's like, well, why did we stop here? All right. So I want to show you something. We're going to start with 1 day. Okay. And I know that I need to get days to seconds. And yes, it's worked out here, but I want to show you kind of something and show you how something works. Okay. And what I want to show you how it works is like a progression and logical thinking behind it. All right. So 1 day, would we think that 1 day is a large number or a large unit, not a number? Let's think of a large unit in comparison to seconds, right? Seconds are, something like that. It's really quick, right? So it seems to be faster than a lot faster than a day. So we're working from a large unit down to a smaller unit. And now if you think about that, logically, what do we know as far as small to big in time or big to small? Well, I know that 1 day equals 24 hours. That 1 hour equals 60 minutes. Well, I'm still not the seconds, and I know that 1 minute equals 60 seconds. You see how we're logically going from a big unit to a small unit, okay? So there's some logic in that. So thinking about if I'm starting with a large unit, should my answer be bigger since it's smaller? Since like seconds, right? Well, should there be more seconds than just saying 1 second is equal to 1 day? That doesn't even make any sense, does it? There is way more seconds in a day, so the answer would be bigger. So you got to think about that. If you get an answer and you know it should be bigger than what you're starting with, and it's not, then that means something's wrong, right? So let's progressively walk through this. So 1 day is over 1, right? Well, if 1 day is on the top, 1 day has got to be on the bottom to cancel. You're going to see 24 hours up here. That cancels. Well, I'm not at seconds yet, so Hours are on top. Hours have to be on the bottom to cancel with minutes up there. Well, I got one more to go because I got minutes on top. And that means they got to be on the bottom to cancel with seconds here, okay? So as you can see, that cancels out just like that. So the thing about this is, when we do the math, we multiply everything up here and we get 86,400 seconds. All right, so 1 day equals 86,400 seconds. So do you see how this can be 1, 2, 3 steps long? These things can be strung together to 3, 4, 5, 6, 7. I think I've seen them as much as 8 long in chemistry before for conversion factors. It's not uncommon for them to be more than one step, okay? Everything we've done so far has only been one step with unit conversions, but they're not all going to be one step, as you've seen. So I stop at this one to show you, yes, it's already done, but I stopped this example to show you that sometimes they can be longer and to think about the progression that you need to get there, all right? Because sometimes you're going to need more than one conversion factor. That's just how it works, all right? So a basin has a volume of water, a volume of 1,500 cubic feet. How many gallons water will this basin hold? Well, this is just like the one we just did. You're starting with 1,500 cubic feet. And here you can see they already did we did the work. 1 cubic foot equals 7.48 gallons, right? If cubic feet are on the top here, where do they need to be to cancel? If they're on the top, they have to be in the bottom to cancel. And as you can see in this conversion factor, 1 cubic foot's on bottom. The thing that's attached to it is the 7.48 gallons. It goes up there. 1,500 times by 7.48 gives me 11,220 gallons. Here in the next example, we have 16,456 gallons of water that need to be transferred to a basin. What is the minimum number of cubic feet that basin must be in order to be adequate to hold this amount of water? So this time I'm starting with 16,456 gallons of water. Well, I know that 1 cubic foot equals 7.48 gallons. This 16,456 is over 1. If gallons are in the top, where does gallons need to be to cancel? On top, it has to be in the bottom. Well, how many gallons? 7.48. 1 cubic foot up top, kind of like that. Just 16,456 over 7.48. Does everything multiply this way, and that's what I got. So 16 divided by 7.48, oops, negative, gives me 2,200 cubic foot. Yeah, I did type them out, just so you see. So you got to take what you're starting with, write it first. Find your conversion factors. If there is factors, there could be more than one. And then use them to get to your desired answer. In this case, it was only one step. We did have to divide in the end. All right. So unit conversions. Okay. I want you to go to page 20 real quick. I'm going to show you how to do number 5 and number 7, and then we're going to work on them. Okay. So here we have FPM, which stands for feet per minute. So there's something about this unit that's different than everything we've done so far, okay? And something that's different about this one is the fact that it says feet per minute. So I wanna, before I write this out down here, I wanna show you something. There's 350 feet per minute over 1, okay? So what I'm showing you is the most common mistake everybody makes. They think that feet per minute go up above here like this. And the thing about it is that is actually not true, okay? So how does this really work? How are we really going to do this? So in order to do this, we're going to give you, how does it written out? So this is wrong, okay? How it's supposed to look is like this. When it comes to these double units, it's best to write the way you say it. And what I mean by that is 350 feet per. Wait a sec, what was per? Per in unit conversions is the fraction bar for this stuff, okay? Per is the fraction bar. So 350 feet per 1 minute. 350 feet per minute. Let's think about one that we all know that we've done for ages. MPH, how would you write that out? You would, we'll just say 55. Well, that's, you know, the most common probably speed limit. Michigan, 55 miles per 1 hour. The per is the fraction bar. The units are not written as a double unit like this on top, okay? If you do that, unfortunately, you're gonna get it wrong. I hate to tell you that, but you will, okay? So 350 feet per 1 minute. With that being the way it is now, I need to get feet per minute to feet per second. So another thing I like to do is I like to write out my answer, feet per second. And the reason I like to write this out when I have a double unit is you can look and compare the two units here. What I mean by comparing the two units is, look, feet and feet. Do you have to convert the top unit? Thinking about it, feet and feet. No, you do not. But then I have minutes and seconds here. This is what I want my answer to be. So do you got to convert your minutes? I do. Think about a conversion factor that has minutes and seconds. Well, I know that 1 minute equals 60 seconds, right? I will tell you straight up, we do not put these on the math formula sheet. We do not put time ones on. I'm sorry, but my 7-year-old can tell you how many seconds are in a minute, you know? We expect everybody to know those. That's why they're not on there. The hours, the days, and hours to minutes and minutes to seconds. We expect everybody to know that. Like I said, my first grader at home can tell me that. So if 1 minute's on the bottom, where should minutes be to cancel? If it's on the bottom, it has to be on the top. And 60 seconds goes here with it. Well, that seems different than what we've done, doesn't it? For the fact that it's double conversions or double factors or units, it doesn't matter if it's on the bottom. It's still, if it's on bottom, well, then it just goes on top to cancel. It's opposite of what we've done. So you times 350 times 1, which would be 350. 1 times 60, which would be 60. And you can see I have feet per second when minutes cancels. So 350 divided by 60 is 5.83 feet per second. Okay. Now I'm going to do this one here. What does CFS stand for? CFS stands for cubic feet per second. Okay, so 9 cubic feet per 1 second. Well, and I want it to equal gallons per minute. GPM stands for gallons per minute. What's GPD stand for here? Gallon per day. Cubic feet per. There is no P here, but it is there per second. Okay, now if we compare our units, I had cubic feet here and I got gallons there. So what's that mean I got to do? Boy, I got to convert that one. Okay, well, I got seconds here and I got minutes. Oh, man. It's not like up here, is it? I don't know. I got to convert both of them. All right, so I know that 1 minute equals 60 seconds, and I know that 1 cubic foot equals 7.48 gallons. All right. My question here with these two, both they got to be converted. Does it matter whether I convert the top unit first or the bottom unit first? Like, can I convert seconds first before I do cubic feet? Or do I got to do cubic feet first? Think about it. Think about it. It doesn't matter. All right. It does not matter. To be honest with you, most people choose to do this one first. And I think it's because of familiarity with the conversion factor. Most people know that 60 seconds is in 1 minute. So I'm going to do that first. So seconds are on bottom. That means seconds got to be on top to cancel. Well, 60 seconds equals 1 minute. So that's why it goes like, not equals, multiply. And now I have cubic feet left, and they're on top. So where do they got to be? They're on top. Where do they got to be to cancel? Well, on the bottom. Does it matter if they're separated by this term? It does not. If it's on the top here and the bottom over here, even though it is separated, it still cancels. So 1 cubic foot goes here, 7.48 gallons. So let's cancel our cubic feet. And now let's look, I got minutes and minutes left on the bottom. I got gallons and gallons left on top. So do my units match? Gallons, minutes? I would say so. So I'm gonna do all the math on here. And you see that we have ones on the bottom here. That means you're not gonna have to divide. It means just ones on the bottom is ones on the bottom. So equals 4,039.2 gallons per minute. Okay, so back on page 19, I want all of you, I'm going to give you 10 minutes to go through page 19 and to try to do the last two on page 20, okay, by yourself. We will go over them, don't worry, it's not like I won't help you. But I want you to try them on your own now, okay? So I'm going to give you guys 10 minutes and then we'll come back at like 10:29 and I'll go through them with everyone. Yeah, I'm still here. I was giving you guys the 10 minutes. I start a stopwatch when I'm doing this stuff, Mike. So don't worry, I didn't go away. I'm still here. All right, here. I just answer that stuff because it shows up here. I don't know if it shows on your screen, but it shows up on mine. All right. So what is the sum? So let's go ahead and go over these. What is the sum of 19 feet, 30 inches, and 6 yards in feet? All right. So the 30 inches and 6 yards are not in feet, but 19 feet is. So I don't need to convert that. So I'm going to start with my 30 inches. All right. This is over 1. Well, 1 foot equals 12 inches. So if my inches are on top, my inches have to be on the bottom to cancel right here, right? So my 12 is going to go there and my 1 foot up here. So I'm going to get inches cancels. So I will get 30 over 12, which will give me 2.5 feet. Okay. The next thing is 6 yards. Well, I know that 1 yard equals 3 feet. So 6 yards over 1. If yards are on the top, where do they need to be to cancel? Well, 1 yard will be here and 3 feet will be up here, which means 18 feet. Well, it wants to know the sum of all of them. So I got to take 2.5 plus 18 plus 19 and add them all up. 18 plus 19 plus 2.5 gives me 39.5 feet total. All right. How many gallons is 7 cubic feet of water? All right, so I'm going to start with 7 cubic feet over 1. Well, I know that 1 cubic foot equals 7.48 gallons. So if my cubic feet are up top, where do my cubic feet got to be? Cancel. And how many cubic feet would I put there? If they're on top, they have to be on the bottom. And I see here 1 cubic foot. Well, what goes on top of that cubic feet? What's attached to it? What does it equal? 7.48 gallons. So cubic feet cancels. 7 times 7.48 gives me 52.36 gallons. 2 decimal places, so that is fine. All right. How many pounds is 9 cubic feet of water? So I'm going to take what I'm starting with. 9 cubic feet. Well, I know that 1 cubic foot equals 7.48 gallons. And what's something else I know about water? Well, I know that 1 gallon equals 8.34 pounds, right? Does this look like I could go cubic feet to gallons, gallons to pounds? Does this look like my path? Yeah, I think so. So I got to get cubic feet to gallons first. So if my cubic feet are on top, where do they need to be to cancel? They're on top here, they should be on the bottom to cancel here. Well, what does 1 cubic foot equal? It equals 7.48 gallons. It goes up top. All right. That would cancel. Now that gallons is what I have left, and gallons is on top, where does gallons have to be to cancel? On the bottom. Well, 1 gallon equals 8.34 pounds, so it will be up here. Kind of like that. Gallons cancel, and that will give me 111 on the bottom, so I don't have to do anything on the bottom, but I have to do this up here. All right. So 561.45 pounds. All right. 19 gallons of water. So I'm starting with occupy how many cubic feet? Well, up here I know that 1 cubic foot equals 7.48 gallons. So if gallons are on top, where do they need to be to cancel? What goes up top then? 7.48 gallons equals 1 cubic foot. This cancels. Now you can see on the bottom here I have 1 times 7.48. So you're going to get 19 over 7.48 like this. 2.54 cubic feet. All right. So on page 20 here, I said 6 and 8 were for you all to do. So I have 750 gallons. Like I said, write it as you talk it out, because the per, when you say per, is your fraction bar. It's easy to do that. Per 1 minute. Well, I want my answer in gallons per day. Now, if you look, gallons and gallons, do I have to convert gallons? No. Minutes and day. I do have to convert minutes to days. Okay, so I know there's 60 minutes equals 1 hour. Well, is that the days yet? No, but how many hours are in a day? Kind of go like that, right? So if my minutes are on the bottom, where do they need to be to cancel? Well, up top. So 60 minutes up here over 1 hour. Cancel my minutes. Now, if hours are on the bottom, where would they have to be to cancel? Up here. Well, how many hours? Remember, I got to get the days here. So it'd be 24 and 1. The hours cancel. So you can see I have 1, 1, and 1 on the bottom, so those won't matter. But on the top, I have to multiply all those together. So this comes out to 1,080,000 gallons per day. That's what I get. All right, one last one here. So the thing about unit conversions is I don't expect you in 2 hours time to be a master of unit conversions. But what I do hope is you'll see that beyond this one, there's more practice. I hope that you practice them because you get better at by doing them. All right. I will say if you're here for the next 4 days, you're going to see quite a few because I have them built in to pretty much every session where you're going to see them every single session because the reinforcement comes from doing them over and over and over, right? That's how unit conversions is best learned. I hate to say it, but by doing them over and over and over, it reinforces them so that you understand them. All right. I didn't learn unit conversions in a day. I remember the first time it was showed to me, I was in 9th grade and we spent an entire week on unit conversions. So it's not like I learned it, snap your fingers, drop your hat. I was very much in the same boat as all of you. So 560 gallons per 1 minute. Well, I want to get this to cubic feet per second. So as you can see here, I have to convert both my units, both top and bottom. Let's think about the conversion factors I might need though. I have gallons and cubic feet. Well, I know that there's 7.48 gallons equals 1 cubic foot. And I know that 60 seconds equals 1 minute. So I gotta get minutes, seconds, I got gallons, cubic feet. Does it matter if I do top or bottom first? It does not. So this time I'm gonna do top first. If gallons are on top, gallons must be on the bottom to cancel. So 7.48 gallons. Well, 7.48 gallons equals 1 cubic foot. So cancel your gallons. Now I can see that I have cubic feet here, and I have cubic feet in my answer. So I'm done converting the top unit. Well, if minutes are on top, bottom here, where do they have to be to cancel? They're on the bottom. So where do I have to put them to cancel? Well, I see 1 minute. It's on the bottom. It needs to be on the top to cancel. 1 minute equals 60 seconds. That's what goes there. So I'm going to multiply everything this way. 560 times 1 is 560. 1 times 7.48 times 60. It's going to give me a number 448.8. I'm going to divide those and I'm going to get my answer. 1.25 cubic feet per second. Okay, so this is the part where I say doing homework helps. Doing repetition of this helps. You're not gonna, like I said, I don't expect anyone in here in 2 hours. Did I give you a hint and maybe give you the ideas of how to do this? Yeah, sure. Some of you may have learned it just from watching me do it. Though some of you may take repetition more for it to sink in. I do apologize, that I don't have a good, David Attenborough voice or Morgan Freeman voice, because now when you ask yourself, should it go on the top or the bottom or vice versa, you're probably gonna hear my voice in your head. And that's not, it's not a good narrating voice, but I try my best, right? So with that being said, that completes what I have for all of you here today. It is, like I said, there is more work back here for all of you, and the answer keys are there for it, okay? So I thank you all for joining us today, and we will see, I think most of you, most likely, most people sign up for all these. I will see most of you tomorrow, but do not leave because there is a poll question. So Matt, I'm gonna go ahead and hand it over to you to complete everything.
Okay, thanks, Scott. Let me get this fired up here. So this next question is just a yes or no question, just launched it. Are you taking this course to prepare for a certification exam? So Scott, what types of things are we going to see in tomorrow's class?
So tomorrow we're going to be seeing the two main areas and volumes that we deal with. We'll talk a little bit about flow rates tomorrow to set you up for the hydraulics stuff that's coming. We'll be talking about a little bit about water velocities and so on and so forth. We'll talk a little bit about temperature conversions because that is important for those of you taking a treatment exam. And again, we'll be kind of hammering on unit conversions and how it all relates into areas and volumes tomorrow. So, those of you who I don't know how many have said yes or no to this question yet, but this class is very geared towards anyone taking any 3 or 4 level certification exam. If you're taking distribution, you will literally see any bit of math that you will see on a S3 or 4 on this test or on the test in this class, or examples of. And then on treatment, I would like to say it covers everything, but it covers the vast majority of it because there's a couple other things that sometimes show, there might be some simple softening questions or simple filtration calculations that we don't necessarily cover in here, but we do give you the tools to do it and solve for those types of questions with knowing unit conversions and with knowing areas and volumes, okay? in order to solve for those simple ones that you might see on a treatment exam. And then if you see like fluoride or iron and manganese removal type questions, chlorine, the dirty secret about it is parts per million equation is the same exact equation that you would use to solve for any of those. So do we give you the tools to solve for them? Absolutely. Do I cover them explicitly with like examples of those questions? No, we do not. Like I said, we're working on more standalone math sessions for those other topics that people may take and don't necessarily see in here, but they need to, want to see it and understand it. So